Saturday, and Saturday for some people is rest day, but here you are learning about cloud. So I'm excited to have you. And it was good to hear your contributions in terms of why you're here. So please, it doesn't matter. You don't need to have a background in technology. You just have to be interested. I don't have a background in tech. And, at some point you'll be in your breakout rooms with different facilitators helping you. They also started with a non-tech background. So please do not be intimidated by anything you hear today. Just take it one step at a time. Most of what you're going to hear today is completely new. That's totally fine. Okay. And as I go along, if you have any questions, please feel free to ask in the chat box. I'll take them at the end. Most likely, I'll be answering your questions even, while I am teaching, right? So which is why we like to take questions at the end. So any question I feel like, wow, she's finished the lecture and she's still not answered it, I'll take them at the end, okay? So let's go right into it. Today, I'm going to be introducing you to what we call cloud computing. And we're going to look at what cloud computing is. Why do you need to learn cloud computing in the first place, right? Why AWS? Because you can see that we're going to be learning about AWS specifically. What is the AWS global infrastructure and how do you choose your AWS region when you're building on the cloud? So please come with me. So what is cloud computing? Cloud computing is actually a technology that allows you to access computing resources over the internet on a pay-per-use basis, right? Over the internet on a pay-per-use basis. So those are the keywords. You're accessing computing resources over the internet on a pay-per-use basis. So what are these resources we're referring to? If you look at this image on the right, we're referring to things like servers, we're referring to things like storage resources, we're referring to things like, applications, your databases, mobile applications as well, all on the cloud, right? You're accessing it over the internet and you're only accessing it on a pay-per-use basis. So let's say, for example, you start a business, you want to sell, different parts of a car, maybe spare parts of a car, and you want to have customers across the globe, right? All you want to do is to build a simple website, right? You don't need to go ahead and get a server because you want to do that. You can easily just leverage a computing platform that already has a server. You build your website there, and when you no longer need the website, you can stop using the server and you only pay for the time that you've used. Or let's say you have a vast amount of data that you want to process and it's going to take a lot of processing power. You already have a laptop, but your laptop cannot handle that vast amount of data. You don't need to go and buy another laptop, right? Again, you can just go into one of these cloud providers, spin up a computer. You're literally spinning up a virtual computer. Spin up a computer, do the data processing you want to do over the period of time, and then you only pay for what you use. They even have free services when you get started. So sometimes you're not even paying anything and you've processed your data and you've destroyed the computer. Or you have a friend who is starting e-commerce and they want to serve 10,000 clients. That requires a lot of computing power. Again, instead of them to start thinking, let me buy a physical server, let me buy this, let me buy that, all they need to do is to go to a cloud provider, access the computing needs that they have, build whatever they want to build, and they continue to sustain it on the cloud. And they only pay for what they use. If their projection of 10,000 customers is significantly less, they only pay for what they use. If it is more than the 10,000 customers that they planned, then they only pay for what they use. They pay for that increase that has happened. So basically, this is what cloud computing is. You're accessing computing resources over the internet on a pay-per-use basis without the need for physical hardware, okay? And we all use cloud every day, either from a little level, maybe you're using Google Drive, Spotify, Netflix, Gmail, iCloud, or organizations even using cloud like Netflix, okay? So come with me. So if you've ever wondered how Netflix manages over 220 million subscribers in views and traffic every day, they leverage cloud computing, okay? And if you ask, how was life before cloud? People had to use, especially large organizations that needed lots of computing resources. Imagine how much computing resources a company like Netflix needs that has millions of movies on their platform, or a platform like LinkedIn, who runs on AWS. LinkedIn has almost 1 billion users on its platform right now. They also run on the cloud. They use AWS specifically. So if you're wondering, how do all these organizations, how do they run so smoothly? It's because they are all leveraging cloud computing. And if you ask, how was life before that? all of these organizations leveraging cloud computing, they had to have physical servers. I'm sure some of us have heard, for the longest, even before I go into tech, I've always known what server is. Like, you just know that when they say, these are the servers, you have a large room that has lots of computers feeding other smaller computers. So most organizations usually have to have things like this, server rooms and all of that. Is, a company, an oil and gas company, for example, they want to, have their own, internal network. They have to use something, and most times they will have their server room somewhere. But imagine if we're telling them you don't need all the server rooms, right? Whatever you want to run, you can run it directly on the global cloud provider, and they can always you can always leverage all the things, all the advantages that are already on that global cloud provider. So if you're wondering how life was before cloud, people had to use physical data centers, physical servers to manage their computing need. But right now, instead of people to come up with all these rooms that have all of these server rooms, all of that can be done fully virtual, fully remotely. All you're doing is you're going to a global cloud provider and asking them to give you what you need. Oh, I need 2 servers, I need 1 database, I need all these firewalls, I need this, I need that. All of that is done on the cloud. And once you finish using it, you destroy it, and you only pay for exactly what you use. Are we together? Do we understand what cloud computing is? Please give me a 1 in the chat box if you understand what I've said so far. And give me a 2 if you are completely confused. So please let me see your responses in the chat box. Okay, let's see your responses. 1 second, I'm trying to check. Okay, I can see understood well, amazing. I can see 1. Okay, do we have any 2s? Anyone that doesn't understand? For this, only 6 people have responded now. We're over 40 on the call. Okay, so we have 1, 2. Okay, can I see? Let's see your response. Some people are on it 2. Okay, can I see your response? 1 if you understand, 2 if you are completely confused about what I've said so far. Okay, we have 1s and we have 2s. Okay, some people are, I think we have more 1s than 2s. Okay, good. Okay. Please make sure you put a response. I mean, want to hear from you. It's for you, and it's for you to understand. So basically, all I'm just saying, for those of you that have 2s, when you think about cloud computing, think of something like Google Drive. Let's give another analogy. Think of something like Google Drive. So if you're using Google Drive, right, what are you doing? Let's say you wanted to put a movie file or a music file, an MP3 file. You have a song that you really like. Back in the days when we didn't have Spotify, you have a song that you really like, and the song is like 100 MB, is sitting down on your laptop, and you're about to go on a journey, right? You want to travel, and your song is on your laptop, right? In order for you to access that song anywhere all over the world, what do? You upload it to the cloud, right? So instead of you putting the song is on your laptop and you're not traveling with your laptop, in order for you to access that song from somewhere else, what do? You simply upload that song to the cloud. So you can move that MP3 file and then upload it to your Google Drive. So what happens? You leave your laptop behind. If you go to China, all you need is access to internet and your login details to Google Drive. You have access to your file already. If you go to France, right, all you need access to internet, your login details, you have access to your MP3 file. Google Drive is an example of cloud computing. So do you see that analogy? So basically, whatever it is that you want to access, you can access it you don't need physical devices. You don't need to carry your laptop everywhere, right? You only need access to internet. You can even use a mobile device. You can use somebody else's mobile device. You can use somebody else's laptop. You don't need your own laptop, right? So the idea of cloud computing is that whether you're an individual, like I just described, who wants to access your music file from all over the world, or you're an organization like LinkedIn, right, who actually doesn't want to manage physical devices. They don't want to manage server rooms. All they do is that they put all of their data on a cloud provider, and anywhere across the world, they can access all that data. Do you see? So that is what cloud computing is. So for those of you that had it too, is it clearer now? Yeah. Banks can use cloud computing to manage their platform. Very possible. I know many banks that are doing it, that all their data is simply on the cloud, so instead of them to actually manage physical servers. So can I get responses back from those that had it too? Is it clearer now? Just those that had it too. Please let me know. You can just let me know yes, no, yes, no. Very quickly. Okay, someone says a yes. I know iPhone actually had it too initially. Can I get more responses from those that had it too? it's important that you understand, okay, yeah, I remember Blessing's name as well. So that's what cloud computing is, okay? So moving on, we have major cloud providers globally, right? We have big cloud providers globally, and these are the three biggest ones. These are the ones that you would have to familiarize yourself with as you, transition into the cloud. So we have the Microsoft, we call them the MAG. These are the biggest ones. We have Microsoft Azure, we have Amazon Web Services, and we have Google Cloud Platform, which we know as GCP. There are other ones. There's Oracle Cloud, there's Salesforce, there's DigitalOcean, there's IBM Cloud. There's so many of them, but these are the biggest ones globally, right? So when I'm saying go to a cloud provider and all of that, so like I was saying, LinkedIn runs on AWS. There are some banks too that run on AWS. There are some e-commerce sites that run on AWS. Do you see? Or run on Microsoft Azure, right? Spotify runs on AWS. Do you see? So different platforms, right? Netflix runs on AWS. So you have all these different companies doing very distinct things. They are using one of those global cloud providers, or sometimes they even combine, right? They're using one or two of these global cloud providers to manage their computing needs. So they don't have to manage all those servers on their own. Now, let's move on to the advantages. I like to ask people the advantage because I feel like once I've described it so well, so much, people should be able to tell me what the advantages are. So I want to hear from you. Based on what I've explained so far, all of you have given me a one. What do you think are the advantages of cloud computing? What do you think, right? Based on what I've described so far, or based on anything that you know of cloud before, what do you think are the advantages of cloud computing? Can I see your responses in the chat box? What do you think? Just have a think about it. Like, based on what I've described so far, what do you think? Very good. Ease of access to personal document. Okay. I like the response. Ease of access and security. Very good. You can save space on your physical device. Exactly. Yeah. Easy access to personal document. Exactly. It makes them control your data. Accessibility, absolutely. It makes storage easier. Yes, absolutely. You can access your database anywhere, anytime. Exactly. It's cost effective actually because you're paying for what you are using. Absolutely right. Right. Easy management of, yeah, you can sell space for money. Absolutely. Because cloud providers now, they give you the space. Whether it's even iCloud is a very good example. Yes, I've been waiting for that. Scalability, absolutely. Yes, you can manage your data without access to physical data centers. Absolutely, which is such a big deal. So you're saving space, you're saving physical space. Because I know of a financial institution that they got to a point where they were almost, it was almost like, are we doing real estate? Because of the amount of, lands that they had to buy to keep huge volumes of servers and data. And imagine them migrated to the cloud and it just made life easier. They have to free up all the land space instead of them keeping servers there. So you guys are totally right. Well done. So yeah, so just like you guys have said, organizations migrate to the cloud, they can now trade capital expense for variable expense. They don't have to be able to figure out at the beginning of their, of their journey as an organization that, oh, how much do we need to actually run our computing needs, because they are paying for what they use. So they can work with variable expense, which is more flexible, right? Which is more flexible. They can also benefit from massive economies of scale. Some of you talked about cost as well, because the more you go use, the less you pay. And they can stop guessing about capacity. You don't need to think and plan up front about everything that you're going to need, right, before you start the journey. And just keep building, right? All you need is an idea. So whether you plan for 1,000 and you ended up having 10,000, right? You don't have any problems because you can easily scale on the cloud. Whether you plan for 1,000 and you ended up having 100, you don't have any problem because you can easily scale down on the cloud and you only pay for what you use. Imagine if you have bought servers that were to serve 1,000 people, you now have 100 customers. You're in trouble because now you're going to have servers that you're not using and it was expensive to buy. Or imagine if you bought physical servers that will serve 1,000 people and now you have 10,000 people. Now it's only until you deploy the application you discover that you actually have more than planned. So what are you going to do? You have to go and start looking for another server. Sometimes to order a server to get it, it can take time, but you don't have that problem on the cloud. There's increase in speed and agility, just like some of you have said. And if you build an application today, it can go global in minutes, because if you had to be managing servers, for you to actually make sure that if you want your server to be close to the end user, imagine if you built an application and people in China are supposed to access that application, right? That means you need to have a physical server in China to reduce the latency. But now you can actually build an application and say, you know what, I'm deploying it majorly for customers in China. All you need to do is to add that setting to your global cloud provider, and they will make sure that, you know, that server is actually deployed to people in the China region. So it is so cool, it's so flexible. And that's why a lot of organizations are moving their workload to the cloud. There's efficiency on the cloud, there's cost reduction, automatic software updates and integration, there's scalability, there's unlimited storage capacity, and then there's ease of disaster recovery on the cloud, which means that it's very hard for you to misplace anything on the cloud. And I'll still talk about that as I go along. So why do you need to learn cloud computing? I'm sure you can already understand why we're talking about cloud computing, why it's a thing, and why you guys are here today, right? I was listening to somebody's vlog online on Instagram some days back, and she was talking about how she's making so much money and all of that. And you know, I was watching her story, and she was like, you know what? If you want to make a lot of money like she is, you know, learn a tech skill. And she was like, oh, it was actually cloud specifically that she learned, that she's blown so well and she's doing so well and all of that. So and if you're looking for a corporate career, even you don't even have to be corporate alone, right? When it comes to different career paths, but if you're a corporate career that will really give you value, a lot of value, income for your skills, then this is the place to be. Cloud computing markets actually moved from a $97 billion market in 2019 to a $217 billion market in 2022. And guess what? The projection, just like you can see on this graph, is that by 2030, which is just 5 years' time, this industry is projected to reach about $1,902 billion market. We're talking about trillion right now. I just put it all in billion so that you can compare, right? We're talking about almost a $2 trillion market here. Cloud is the future. And if the market share is this huge, if there are many people that are investing in the cloud, moving their workload to the cloud and all of that, what does that mean for you? Organizations need people that actually have these skills. And that's where you come in. There are going to be more jobs, more skilled professionals needed, you know, to actually meet this demand. And it's on an all-time rise. Now, moving on, if you ask why AWS specifically, because that's what we teach here at Cloud Boost, and there are other cloud providers, right? AWS is the biggest cloud provider at the moment, because these cloud provider organizations, right? You never can tell. Things change very quickly when it comes to the tech space. But at the moment, AWS has the largest market share. They were first to actually go into this cloud computing space, and they have more services than any other cloud provider. And learning AWS actually lays the foundation for you to learn and adapt to other cloud platforms, because it's easy to comprehend. Its documentation is very, very user-friendly. After AWS, we have Microsoft Azure. After that, we have Google Cloud and other ones. And the good thing is that any organization that wants to hire you, they look at your computing skills. We have people get jobs, Microsoft Azure jobs with AWS skills, AWS jobs with Microsoft Azure skills. So they are very interchangeable. The key thing is for you to understand how cloud computing works, and you can adapt that to any cloud provider. We don't recommend you combining too many cloud providers at the beginning of your career. Learn one first, master it first, and then you can start learning about the other ones, okay? Now, again, I'm already beginning to wrap up the first part of my lecture, and if you have any questions, please feel free to put it in the chat box. If we go to the AWS global infrastructure, you know, just having a view about what AWS is like on a global scale, we have what we call an AWS region, right? And an AWS region is simply a geographical area in a country where AWS actually operates, right? So AWS doesn't operate everywhere at the moment, but they have different countries that they have a presence in. So, you know, we have United States of America, you know, we have United Kingdom, South Africa. These are some of the places that they actually operate, and they continue to expand globally. So right now, AWS actually has about 38 regions globally. And by region, we mean a geographical area, right, where they actually operate. So we have about 38 of them globally. And if you go to this link, you can see more you can see the specific places, and it's also showing here, right, the different places that they operate. So that's what we mean by an AWS region, right? A geographical area in a country where AWS actually operates. Part of the global infrastructure, we also have what we call the availability zones, right? And these are isolated data centers that are located in specific regions. So as much as I'm telling you guys that, cloud, you don't have to worry about physical servers, move into the cloud, go to a global cloud provider. So these global cloud providers actually have what you see. They actually have rooms like this where they are the ones that are managing the headache of all these servers. So it's not as if servers don't exist again. It's just that all the physical servers, we want them to just be managed by the global within availability. I mean, they have all these data centers, which are, they are in all these different regions that I'm talking about. So imagine if AWS already has all these data centers, which contain servers, right? They already have it all around the world. They have it in China, they have it in Australia, they have it in different parts of the world. So if I want to build an application and I want to serve all those customers, I don't need to have physical servers in all those spaces. It's going to be expensive for me. So I just go to a cloud provider that already has that presence, and I rent what I need, and I tell them, use your server in China for this particular part of the workload. Use your server in Australia for this particular part of my workload. So it just makes life so easy for you as a cloud professional, as an architect, as a developer, to just leverage what AWS and all these global platforms have already created. So availability zones are isolated data centers located within specific regions. So AWS has places in the world where it operates: Ohio, North Carolina, North Virginia. All these are different regions that AWS has. Now, so within those regions, they now have specific rights, and that's what we mean by availability zones. So within North Virginia, they have 3 availability zones right there, right? Do you understand? So a specific region in North Virginia where they have the availability zone, where they have their data center, is what we know as an availability zone. So availability zone is a subset of a region. So, and what this does is that it helps to ensure that cloud customers have stable connection to a cloud service in the geographical zone that is closest to them. So with all these things that I'm describing, right, you want to build an application, you want to serve Asia, you want to serve the world, right? So all the people in Asia, they can have the application in the availability that is very close to them. It won't be that all your workload, even though you're serving the nations, it won't be that all your workload is just within a particular region, right? It will be that your workload is distributed close to, the people that it's going to serve, and it's going to significantly help in terms of what we call latency, which is, how far, your deployment is from the customers that it's going to serve. So global cloud providers have all these isolated data centers within specific regions, and this is what we call availability zone. So a region, once again, is a geographical location, within a country, where AWS actually functions. So London, for example, is an example of a region, right? And then availability zone is like a building that has tens of thousands of servers, right? Which we refer to as data center. So each AWS region actually has 2 or more availability zones, right? And then availability zones consist of a data center or groups of data centers. Do you see? So don't mix it up, right? Because this is very important. They test your understanding of this a lot. Region, a place within a country that AWS operates. Availability zone, a building that has servers, lots of servers. And these servers, these groups of servers, we refer to them as data centers, okay? So, and then how do you determine your AWS region? There are 4 major things you think about when you're trying to determine your AWS region. And as I begin to wrap up, okay, so you think of something we call the data sovereignty laws. There are actually some countries that will tell you that the data in that country, you cannot move it outside of that country. You know, we have what we call GDPR laws. You know, a country like the UK or America, they're very particular about, you know, their data. So data sovereignty laws, if you think about it, are there restrictions where my data resides? You know, are there any federal requirements? You have to comply with that. And then you have to think of latency to end users as well. You cannot build an application for people in Australia and then you keep your data center in Africa. No, the data center has to be close to where your region, the region where you're operating, and by inference, your data center has to be in a region that is close to your end users. You also have to think about services as well, the services that you want to use. What region have your required services, right? So for at the moment, US East 1 actually has the most AWS services, and that's where AWS releases services first. So whatever it is that you want to deploy, you have to think about it. You can't deploy in a region that doesn't have the service you want to use. And then finally, you need to think about price, because some prices actually differ from region to region, and AWS is very transparent about this on their page. So you can always make that decision about it. So we have all of this. These are things that are part of your AWS region and things that you need to think about. And then finally, we also have something called the AWS edge location, right? And an edge location is actually an endpoint that is used to cache or store content. Now, this is important. I know some of you probably have the question already that, okay, what if I want to deploy something in a place where AWS actually does not have they don't have those availability zones? What if I want to deploy something, in a place where AWS does it? Because AWS, like I said, they are only available in 38 regions globally. And within that, they have availability. So they have 120 availability zones. So there's still other parts of the world that do not have AWS availability. So you may be thinking, so how do we manage that, right? How do we manage that if I actually want to deploy my applications closer to people that, closer to an end user, but the end user is not within the AWS global infrastructure? So we have what we call edge locations, right? And this is a place, this is like an endpoint, like mini servers that AWS actually has across the world. So even if they don't have these big buildings that are data centers, which have servers in it, in some cases, they even partnered with third parties, right? So actually have all these little servers across the globe. And that's what we mean by the edge location. So what happens is that if you need to access, if somebody, for example, you've built your beautiful e-commerce website, or your little clothing business, right? You've built your clothing business and you want to serve the globe, right? Your projection was that you would have customers majorly in India and Australia. And now all of a sudden, people in China are trying to access your website. So what happens is that if people in China, the first time somebody in China accesses that website, all that detail the website will be served from India, which is closer to China than Australia, right? So now, all that data that you want to access from, all that data that your customer is accessing in China is going to be served from the India availability zone. But in a case where you have enabled what we call edge location, what edge location does is that there's going to be another server somewhere in China that once the first person accesses your information and they're sent from India, all that data is actually now going to be stored in a mini server in China, so that anybody else from China that needs to access that information, right, they access it directly from China instead of everybody feeding from India or even as far as Australia. So the idea of edge location is that there are still many servers across the globe that AWS leverages, right? Either, owned by them or even just, actually using it alongside a third party. So the idea is anywhere that your anybody that accesses your website, which is built on the cloud, if it is not within their own region, all that details can actually be saved in their region. And anybody else in their region that needs to access that data, they access it from where it has been cached or it has been saved, okay? So, and it makes it easy for them to access. So this is just an extension of how AWS operates. So we've looked at the AWS region. We've looked at region, a geographical area where they operate. We have availability zone, right? A building that has tens of thousands of servers, right? That have data centers where, you know, that AWS uses to service customers. And now we also have what we call edge location, which is like endpoints where data can actually be stored. And this is completely optional, right? It depends on how you're building your infrastructure. And that's what you will notice as a cloud engineer. As a cloud engineer, you have a lot of flexibility around what you do. You just think about the case study and think, do I really need edge location? If you don't need it, you don't enable it. You don't need everything, but you need to understand what is available and how the cloud works. So I know that you guys are just hearing all these things for the first time, so give yourself time to absorb everything. But if you have any questions, please let me know. So at the moment, AWS has about 38 regions. They have about 120 availability zones, and they have over 700 edge locations. So an edge location is a physical server location where AWS stores cached copy of your content closer to the end users, okay? And this is an idea. All these blue dots, this is where you can see where AWS is. And, you know, the gold, you know, circles are actually the regions where they operate. So you can see that the edge location is beyond just the regions that they operate, right? So they can have edge locations and all of that. So that is your introduction into the world of cloud computing. Please, any questions at all, bring it on. We're here to help, okay? Can edge location be a mutual ground between AWS and end user? Please, can you clarify what you mean by mutual ground? Expand your question so that I can explain properly. What do you mean by neutral ground? Mutual ground, okay? I saw a blue dot in Africa. Where is that? That is South Africa. That is South Africa. You know, yeah, this is South Africa. But at the moment, AWS, let me show you guys the most recent one. Let me show you, let's go to this site so you can see it properly. 1 second. So if you go to this site, so this actually, let me put it in the chat box for you so you can explore it. So that's AWS Global Infrastructure, okay? Sorry, 1 second. So you can see different parts of the world. So this is Africa, right? Yeah, so AWS actually has a region in, you know, Cape Town, South Africa. They have it now. They have it now. Initially, they didn't have it. It's new. And that's actually the only place that you have data centers in Africa. But again, does it mean that Nigeria, other places where West Africa, East Africa, you can't use AWS? That's not true. You just have to select a region that is closest to you, a region that is going to serve your end users, okay? There's some other parts of the world that they have more. So this is Europe, Frankfurt, Germany. This is Paris. This is Zurich, Germany, Milan in Italy, you know, so they have a region in Spain as well, you know, Saudi Arabia, some of them coming soon, right? So you can actually look at this globe, move around if you want to see the places that AWS actually operates. You know, this is Thailand, Singapore, you know, they've got regions all across the place, right? All across the globe. And of course, this is a list of it. So these are, okay, so you can see from EU West, they have 3 availability zones there. Let's look at Canada. So within Canada, they have 3 availability zones in Canada, right? They have 3 availability zones in Canada. So let's see. Canada, that's Canada Central. Canada West, Calgary, they have 3 availability zones right there. So yeah, I was mentioning Ohio earlier. This was launched in 2016. So within Ohio, they have, and when it comes to edge locations, so you can see, you know, just this North America alone has 31 availability zones within 9 geographical regions, and then they have 31 edge locations. That's just for North America alone, right? So anyway, you can see the details. So this is just North America. If we go to Africa, let's look at their coverage in Africa. So within Africa, you can see they have just the region, Cape Town region, and then within for the edge location, you can see AWS Cloud in Africa has 3 availability zones with 1 geographical region, and they have 4 edge locations. So even though they only have a region in Cape Town, you can see they have 4 edge locations. So they actually have an edge location in Cape Town, the same place they have a region. They have an education in Johannesburg. They have an education in Lagos, Nigeria. They have an education in Kenya. So we can leverage that for deployments. Do you see? So you can check all the different Middle East as well, see how many regions they have, Australia. So this website is really good, and it really guides you on the things that are available on AWS. Let me see your remaining questions. Okay. Why are there no centers in Africa? They are computing you gradually. I mean, the Cape Town region actually, I want to check when, yeah, it was launched in 2020. Yeah, because I know that when I started cloud, it wasn't there. So that was launched 5 years ago. Some of them were launched in 2016. So they're building it gradually, but yeah, so that's for AWS specifically anyway. So yeah, they're really gradually. And I mean, I don't want to speak any negative about Africa, but sometimes, sometimes some regions may be harder to establish these things than other regions. But again, they're building it gradually. But again, like I said, they have edge locations in Lagos and Nairobi, Kenya, which you can leverage. And a lot of people in Africa are actually deploying on the cloud. So don't say that, because you have a region. You don't need to have a region there. You can still do your cloud deployments. How do we access these edge locations? So, as a cloud professional, right? All you need to do, anything that you want to access on the cloud, you simply just go into the cloud environment and enable the feature. You don't need to, you just need to know what do we have available, right? And then you enable the feature. You don't need to go and see the edge location physically. I'm sure that's not what you're referring to. But yeah, so as a cloud architect, all of this is on the cloud platform. So depending on what you're building, if you feel like that's a feature that you need, right, just go ahead and enable that feature. Okay. By your description, only South Africa has an availability zone in Africa. The only region, not availability zone, now the only region. Now within that region, there are availability zones, but yeah, the only region that AWS currently has in Africa is the region in South Africa. Okay. Yes. So, okay, thank you. I think Michael has posted something on Cape Town specifically. Ma, is there a placed backup plan? If anything should happen to any of the data in a region, and if no backup, what happens to the cloud if this eventually happens? Very good question by iPhone. Why are you not using your name so we can address it properly? Yeah. So yeah. One of the major advantages of the cloud is disaster recovery. And what do we mean by that? It means that it's very hard. Like, any data that you keep on the cloud, there's 99.99% assurance that nothing is going to happen to that data. And part of the reasons why we have this confidence is because of this concept of availability zones and all of that. So anytime you deploy anything on the cloud, you're not just deploying it in one specific place alone. So I've talked about region, I've talked about availability zone. So if you want to build an application, for example, as a cloud architect, what we encourage is, and when you're building your application, right, even when you select that, okay, the major region that this application is going to serve is, North Carolina region, we advise that you use at least 2 availability zones within that region. So what happens is that your data is not just residing in one place. You actually have 2 different availability zones serving your application. So that means that if anything happens, and the only thing that can really happen, because they've built this systems to be so resilient, the only thing that can really happen is maybe natural disaster. Even fire, they've simulated with fire. It's only maybe you have an earthquake or a tornado, something that is completely beyond human control. And it's not that. These are things that are still areas where, they make sure that even with all these kind of scenarios, as much as possible, don't lose anything. So let's even assume worst case scenario, right? There's been a tornado in a region where your data is. Because as a cloud architect, you've thought about high availability initially before you build your application. your application will be served by the other region. So as a cloud architect, right, you make that call. All you need to know is that AWS has so many regions, has so many availability zones, but it's your decision to now decide that, okay, these are the availability zones I want to use. This is how I want to build my application to be resilient. This is how I want to build my application to be redundant. This is how to be resilient, right? To be reliable. This is how I want to build my application to ensure that if anything to be available as well, which means that no matter what happens, if anything should go wrong, right, my application is always there. So as long as you factor that in your building, if anything goes wrong with one region, your information is always available, is always set from another region. And these are things that we teach in Cloud Booster. There's actually a whole topic on high availability. How do you actually build applications that never go down? There is a way that you can do it on the cloud. Now, there are some things that if you put it on the cloud, you don't mind if anything happens to it, because maybe, for example, you can easily recreate that thing, right? There are also applications like that. So in that case, you don't need to stress yourself. There's also a whole thing around backing up on the cloud. That's something that we enable, even if it's not from sake of availability, even if it's just for the sake of track record. You just want to make sure that anytime, we do it a lot in the cloud space. I mean, all that times that, there was an organization I used to work for that every single day we generate backups of our application. We keep backups because it's not just if the thing should go down. There's also the scenario where somebody can make a mistake and destroy something on the application. And we've had cases like that a lot, where somebody just deploys something and everything broke. What do? We just quickly go back to the last backup we had, we restore it, and any of the little changes between the backup time and where we are right now, we just quickly make those updates. So there's an entire thing around how to properly back up your systems on the cloud. And we also talk about it in databases on the cloud as well. So there's a lot more depth to everything I'm saying. I'm just giving you overview. But yeah, your data is secure on the cloud, depending on how you deploy it, okay? So what's the difference between a cloud architect and a cloud engineer? So most times an architect, I always compare it to a building architect. An architect gives the blueprints as to how things will fit together, right? Oh, I want to build an application for 1 million users. I'm going to need, an architect will put together, okay, these are the services that you need. You're going to need an AWS EC2 instance. You're going to need firewalls. You're going to need guard duty. You're going to need elastic load balancer. You're going to need this. Put it together and give us an architectural diagram. A cloud engineer goes ahead and actually configures. They do the configuration. They can do all the infrastructure as code as well. So on a broad view, an architect gives the blueprint of the solution, right? And an engineer actually goes ahead and builds that solution. But you cannot be an architect without you can't just become a cloud architect. You need to have a foundation of actually building and understanding how things fit together before you can be an effective cloud architect, okay? So, kindly forgive my kind of stuff. Just iPhone, please, Justina. Nice to meet you. You don't need to apologize for that. These are really great questions, and every now and then, guys, like every IT system and every IT organization that is serious, they actually simulate disasters in fact, sometimes we go to the extent of actually infusing virus into IT systems. It's just because you have to plan for every scenario. So sometimes you're building an application and you actually intentionally put virus inside and see how the application responds. Because if you can successfully put a virus in your application, that means somebody else can do it, right? So you have to plan for every scenario possible. It's part of your journey as a cloud architect, okay? So somebody that just joined, you watch the replay. You just joined at 9:15. You want me to go over everything, John? Don't worry, you watch the replay. And if you have any questions, don't worry, there's support available for you during the week as well. Okay. Yeah, so again, I think the answer I gave around backup, recovery, high availability, it applies to your question as well, Wale. So there's a whole lot around how to properly back up, depending on what you're doing. But you can be rest assured, anything you keep on the cloud, there's a way to actually recover your data. Your data cannot be missing. Okay. Can you save sensitive information on cloud? Very good question as well. Yes, you can. And again, depending on how sensitive your data is, there are also some specific AWS services that are used for the purpose of sensitive data. There's something we call PII, personal identification information. Those are very sensitive data. A lot of banks handle it, financial institutions. So depending on the level of sensitivity of that data, you will decide what service you want to use. right? So you could use AWS Macy, for example. That's a service that you use when it comes to PII data, and you can actually just even store your data in an S3 bucket, right? And just make sure that you have encryption enabled. I'll talk about it on my second lecture, how to store data on the cloud. But yes, people store confidential data all the time. Relationship between cloud engineering and AI is a two-edged sword. Cloud enables AI, AI also enables cloud. So AI, artificial intelligence, needs somewhere to happen on. So even as much as you have ChatGPT giving you all those outputs, right? You create a prompt, and ChatGPT gives you a response and all of that data that feeds AI, that makes AI intelligent, it has to be stored somewhere. And that's where cloud comes in. All the prompts that you've put on your ChatGPT over time, or all the responses, they have to be stored somewhere. That's where cloud computing comes in. So AI runs on the cloud, right? And you can also use AI as an enabler for your journey as a cloud engineer, which is what, I mean, for people that are coming in for this course, we're really going to go in depth into that. For this course starting 18th of October, we have a whole module on how AI actually enhances your cloud journey. So is the two together. You cannot have AI without cloud, because cloud is the infrastructure that AI needs for data processing and all of that. And you can also use AI to enhance your cloud journey in terms of actually leveraging, artificial intelligence. Just like right now, even software development, can be enhanced using AI. Sometimes I was speaking to a software developer the other night. I was like, back in the days, it was the code that I wrote for 3 months. He used AI for the code, and within a couple of days, the same thing was developed using AI. So the same thing on your cloud, you can enhance, you can use it for troubleshooting and all of that. We use it, a cloud booster. So it's both ways, okay? So what is a good way to start a role in a SOC? What's SOC? Forgive me. That was SOC. How can we start up? I guess learn somewhere, pass, get certification, then build whatever on GitHub your portfolio. Just an idea, your idea. Oh, of course, that's the pathway. Really, you have to learn. You have to expose yourself to projects, and then you have to be visible. So after you learn, you put yourself together, put your projects together. You have to be visible. You have to use LinkedIn. You have to use CV. You have to be ready for your interviews. You have to be ready for, technical interview, soft skills interview. You have to be ready. You have to make sure that before you're ready for that, you have to make sure that your CV is good, your LinkedIn profile is good, so that it can be attracted by recruiters. And after, prepare for all those interviews. By the time you go through those interviews and all of that, sometimes it may take a while. You may need to do a number of interviews before you actually get your dream job, okay? So that's the part where you summarized it nicely. You need to have your portfolio as well. So how long I'm still in school, law school you're still in school, law school up next. So it depends on you. Do you want to combine it with your law school journey, or do you want to take it when you finish law school? Okay, so it depends on you. Okay, Security Operations Center. What is a good way to start a role in a Security Operations Center? So if you have a Security Operations Center that you want to work in, it depends. If they're leveraging the cloud, you can introduce the cloud to them. If they're already leveraging the cloud, then you can help them build their solutions on the cloud. One thing I want to mention, as you mentioned your Security Operations Center, one thing I want to mention is that some people also that have a cybersecurity background, they come to meet us and be like, oh, how can I leverage the cloud? We actually have people that, they combine their skills within the cybersecurity space, leverage cloud computing, and then they get into the world of cloud cybersecurity, right? So there's a lot you can do. Some people are in completely different fields. It's not related. You can be in the healthcare, and I talk about this a lot. Don't worry, I'll talk about it at the end once we finish, because I'm digressing. I thought you guys asked questions. But anyway, let me just touch on it briefly, very, very briefly. You can be in healthcare, you can be in anywhere, history, whatever, any course you study. By the time you learn cloud computing, you can now begin to see areas within that course that you can maybe automate. You can begin to see how you can deliver your work within that field completely differently from how you're doing it at the moment. So, yeah, okay. Let's take all the questions that are related to career and everything. I've actually answered it already, but if you still need more clarification, let's take it at the end of the bootcamp, okay? But I also answered questions related to this module I taught. So well done. Thank you for participating. I love it when there are lots of questions. It means you guys are listening. So we're going to take a quick break now, and then we'll go to the second lecture, and then you guys will actually build solutions on the cloud. There's also going to be quiz. You guys build solutions on the cloud, and it's going to be an amazing time. So please go ahead and have your break. and then you come back and then we'll continue from where we stopped. Thank you.